So as promised, here's a video on scientific notation. Scientific notation, like it says, is really useful in the sciences, especially chemistry, physics, astronomy. A lot of situations where we're going to be dealing with really, really small things or really, really big things. For instance, there's a conversion you use all the time in chemistry, which gives you the number of atoms per mole. So that conversion tells you there's 6.02 times 10 to the 23 atoms for every 1 mole of a substance. So right here, this is an incredibly big number, right? So as we discussed in class, there are 3 things we're going to have to do with scientific notation. One is to be able to go back and forth between scientific notation and what we would call standard or decimal notation. So this is about 2 things in my opinion. One is deciding, is this number going to be big or small? Big meaning that we're multiplying by tens, or small meaning we're dividing by tens and then going into a decimal. Big is going to have the exponent as a positive exponent, and small means that we're going to have a negative exponent. And that's really what most of it's about. The other piece that's super important, especially when we get to those tricky multiplication and division questions, is that we need our number piece out in front, because our scientific notation looks like this, right? We need that A must have only one non-zero number in front of the decimal. We can write that mathier by saying that our A has to be strictly greater than or equal to 1 and less than 10, right? So 1 and above is great because we have a 1 point something. We can't get up to 10 because that would have 2 decimal points. So we use the strict less than symbol to mean that 9.99999 is fine, but 10 is not. So in this case, we're good because there's just one number in front of the decimal and it's not 0. So converting from scientific notation to regular notation, first thing I'm going to do is look at the n, our exponent, and go, all right, that's a big ass n, which means, because we have a positive exponent, means we're going to make a big number. So when I move my decimal place here, I'm going to move it to make this number gigantic, right? And then move it 23 spaces in this case. So the easiest way to do this, rather than do a ton of different little loop-de-loops and then you might lose a 0 somewhere, is just think, okay, from here to here, I've moved it 1, 2, and then I'm going to need 21 more, right? Because this is 2 of my 23, so there's going to be 21 more, which means I'm going to have 21 zeros after those numbers. So 602, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, oh my god, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And then to make life easier on me as the teacher, you could go ahead and put little commas every once in a while. That way I can really easily count up how many zeros you've written. But on the test, I didn't give you anything quite as gross as Avogadro's number here, this number of particles or atoms per mole. But now you see why it's so useful in science to use scientific notation, because that's a lot easier to type into a calculator or even write down than it is to have all of those zeros. And your calculator can't handle all of those zeros. It would, the screen is only so large. So then we can also go the other direction. So I'll give you an example of that. What if we had 0.0734? Going in the other direction, we kind of want to start with number 2. And that is to go, okay, where do we want that decimal place to be? So in this case, we need just one number in front of the decimal that's on 0. So we want our 7 there. Second thing we're going to do is we're going to say, okay, this thing is small, right? It's a tiny number. It's a decimal. So I already know part of my answer, 7.34. I already know that whatever happens as my exponent's got to be negative because it's a small number. And then I just have to count how many places did I move my decimal. How many tens did I divide by? So in this case, 2. One thing I will say, a big note from when I was grading everything, especially on the ones that you're rewriting into decimal form. So I had a lot of people who had something like this, 7.34 times 10 to the negative 3. I'll change it up just slightly. A lot of you guys did this and then just left it. This has, especially for those of you who don't have a different color pen, has 2 decimal points in it. I don't know what the heck you're saying. This is your work, right? What I want to see at the end is your answer. I want to see 0.00734 boxed up pretty by itself. So don't confuse work with your answer. Don't assume I'm going to look at this and go, oh, I know that I'm going to look at this and say, I don't know which of these 2 decimals they're talking about. 2 decimals inside of a problem is not allowed. I'm not going to give you points for this. You need to give me something pretty. All right, so that's writing things in both standard and scientific notation form. Like I said, just comes down to 2 pieces. Is it big or small, right? Big being greater than 1, small being less than 1. And then does it, the idea that we only need to have 1 non-zero number in front of that decimal.